Hey class, this is Mr. Roberts at Shasta High School, and I hope you're having a good break away from school. I did promise several students that I would go ahead and record the solutions to the study team test from Chapter 4. These tests have been placed in your Drive folder, so you should be able to go in and look at how your team did. But also, sometimes when you're working with other students, it's kind of what the group knows, and maybe you're kind of still, developing your understanding. So it's a good idea to kind of go through these before we take our individual tests soon. So let's go ahead and take a look at these. So the very first question gives us two situations. One of them is we have the function f of x equals x squared plus 4x. And we're asked what's the output when -3 is the input to this function. A challenge that we have is often I see this is we're still kind of not exactly sure what's happening with this -3 that gets squared. I understand if I slow myself down and think about it, when I square -3, that means it's a -3 times another -3. -3 times -3 is exactly the number 9. So I think where one of the problems might be is when we're writing this down, we should say, look, x is going to get squared, and then we're going to add 4 times the value of x. Now that I have that set up like this, I can say, well, what is x? Well, x is the value -3. I'm going to square that, and then I'm going to add 4 times that. So if I place this number in here like this, there's -3 and there's -3. Notationally, this is not going to be a problem if I evaluate this with my calculator. -3 squared, like that, right, will produce the value of 9. And then 4 times -3 produces the value -12. So this is 9 plus -12, which is -3. So y will equal -3 when this function is passed. That's interesting. Y equals -3 when 3 is passed to this function. Let's look at the next question. The next question flips this and says, hey, look, what I'm interested in now is what input produces this particular output. So probably the easiest way to do this is say to yourself, look, I'm interested in when 1/4 x plus 80, I'm interested when that will equal 120. So by setting it up this way, it's just like, I want to know when the output of that function is 120, right? Again, this is the definition of the output. When does this output produce a value of 120? Well, solving for x is going to give me exactly that. So I can begin by subtracting, 80 from each side. So I get that 1/4 times x is going to equal 40. And then if I go ahead and multiply both sides of this equation by 4, over here times 4 is going to give me x, and on the other side multiply by 4 is going to give me 160. So I believe it's true when I pass 160 into this function, it produces an output of 120. And I can verify that, right? 1/4 times 160 is 40, and 40 plus 80 does give me 120. So this checks quite nicely. Let's go to question 2. Question 2 had 4 expressions, all of them monomials, right? If you'll notice, there is no addition or subtraction anywhere. It's just one thing times another thing. Of course, we've got the squaring and a bunch of other things going on. So the directions say, hey, simplify these expressions. Answers may not contain negative exponents. So once you're done, the answers can't contain negative exponents. So the first thing is I just say, hey, I'm multiplying two things. If I wanted to conceptually, I could even say, look, I could use an area model. Literally, I'm taking one thing here, which is x squared squared, and I'm multiplying it by this other thing, x cubed y to the -7th. And the question is, what do I get when I do that multiplication? Kind of a mess. So let's go ahead and just go through this and begin. So if I take x squared and I square that, right? X squared squared, that's going to be x to the 4th power, right? 2 times 2 is 4. This says I've got 2 of these things, right? So there's an x squared times another x squared. So x squared times x squared is x to the 4th. And I'm going to multiply that by x cubed times y to the negative 7th. So that's nice, right? I can go ahead and choose to look at these and associate the negative 4 and the x to the 4th and x to the 3rd. X to the 4th times x to the 3rd is x to the 7th power. I'm still multiplying by y to the negative 7th power. And if I want to get rid of that, any negative power, right? Any negative power, once it's looking like this, I can just multiply this by y to the 7th power over y to the 7th power. Why can I do that? I'm multiplying by the number 1. I can always multiply by the number 1. Why did I pick this particular value of 1? Because there's a lot of different ones I could pick. The reason why I selected this value of 1 is in the numerator, when I multiply y to the negative 7th times y to the positive 7th, that equals y to the 0 power, right? This equals y to the 0 power, which is just the number 1. Anything to the 0 power is 1. So in my numerator, what do I have? I've got x to the 7th power times the number 1. And in my denominator now, I've got 1 times y to the 7th power. So this is our final version, right? This is x to the 7th over y to the 7th. Let's move to part B. Okay, so B. I guess I'm going to choose to get these values, these numbers closer to each other. So I'm going to commute some things around here. So in my numerator, I do have 2 times 8. I can write it as 16, but I'm choosing not to at the moment. In my denominator, I've got 48 times the number 4. And then in the numerator, there is a x times a y to the 8th. And there in the denominator, there's a y to the 10th times y squared. So looking at the denominator, this is y to the 12th. So I think for my next version, I'm just going to change that to y to the 12th. In the numerator, there is an x times a y to the 8th. So I think I'm going to go, I can't forget there's this number I have to deal with, right? What this at thing, right? That's not the number 1. I don't think it is anyways, but I don't want to forget to deal with that. But let's go ahead and deal with this x times y to the 8th over y to the 12th. Well, I've got 8 factors of y in the numerator and 12 factors of y in the denominator. That's going to leave me with 4 factors of y in the denominator. So I've got this x and a y to the 4th power that's down at my denominator. Okay, so there's one last thing here, the number, right? So I do know that 8 divided by 4, you know what? I'm tired. I'm just going to grab a calculator. Mr. Roberts. I mean, I can't say that's 16 over, this is 16 over 4, which is 4 over 48. Divide that by 2, it's 2 over 24. Divide by 2, it's 1 over 12. Okay. I guess I didn't need a calculator, right? So I believe this is 1/12. So I think my final answer would be it's 1 times x, so x, and in the denominator, it's 12 times y to the 4th. But I do understand that I have a good ability to make mistakes, so I am actually going to grab my calculator and just confirm that that number is correct. So let's see, where is the there it is. So I'm just going to go ahead and look at a numerator with 8 times 2 and a denominator with 48 times 4. And I believe this should give me 1/12. Oh, and it does. That's great. So I'm very happy with my answer, but I'm also happy with my decision to go ahead and check that arithmetic because I know how that can go sometimes. All right, let's go to part C. Ooh. I think I'm going to start with the arithmetic this time. So this time I do have this 4/3, and that's going to be multiplied by 6 halves. One of the things I'm noticing is that neither one of these sets of parentheses are being raised to a power. So I don't have to worry about the fact that I should be increasing that. It's not to the, that first set of parentheses is not being raised to the second power. So I can go ahead and just deal with this 4/3 times 6 halves. 6 halves is the number 3, right? So I might just back this up here and say this is the number 3, and I'm multiplying that times 4/3. Oh, no, not 4/4, 4/3. And actually, if I take 4/3 and I multiply that by the number 3, what do I get? I get exactly 12/3, which is 3. So I'm going to have a numerator of 3. That's fabulous. So I think that's a win because I'm not having to deal with a fraction. So our numerator has a 3 in it. Well, I don't have to deal with these fractions anyways. Let's see. Across the numerator, there is a factor of a times b cubed times 4 more factors of a. So across the numerator, I see I've got an a to the 5th, b to the, oops, not a, b to the 3rd, and then down in my denominator, I have an a to the 5th, which is great because I can see that I have this common factor of a to the 5th. So there's a 1 form there. So my final answer for this, if I look across the numerator, there's just a factor of 3, and then there's b. So this is going to be 3b to the 3rd power. Now, I'm going to pause right here and just say, okay, I'm suspicious of my work, right? How would I perhaps test this and see if I'm correct or not? Kind of a tough question, but one of the things you can do, and I don't know that I super recommend it, but certainly if you're done with the test and you look up at the clock and you've got 10 minutes, you can always play this game. And it's just kind of nice conceptually to think about what's going on. So I could, right, pick some random value and store it for a. So I'm going to say 2.561, and I'm going to store that in. And if I hit this 1, 2, 3, there it is, a. So I'm going to store that in for a. And then I'm going to store the number, I guess, negative 12.3. I'm going to store that into b. There we go, b. So here's the game you can play. My simplified version, my answer is 3b to the 3rd. 3 times b raised to the 3rd power. So my simplified version produces this output for the particular b that I selected, right? I selected some random b. For the particular b I selected, that's what my answer yields. Now, it's no guarantee that I'm correct, but if this doesn't check, there's definitely a possibility I'm wrong. So what I could do is I could look at the original expression, which looks tough to enter, right? But I've got a fraction. In the fraction, I have parentheses, and then I have a fraction that I start with. In the fraction, there is 4/3. There's 4/3. And then I've got times an a. So I'm just going to go grab an a. And then I'm timesing that by a b. And then I'm raising that to the 3rd. So there I've got 4/3 times a times b. I'm going to close those parentheses and I'm going to open them. And now I'm going to have 6/2. I'm so sure that 6/2 is 3. I'm just going to confidently type a 3 there. Except what if I'm wrong? I can't be wrong. There's no way 6/2 is not 3. So I'm just going to put a 3 there. And then I've got this a raised to the 4th power. All right. So that's the numerator. The denominator is just a raised to the 5th power. Now, when I press enter, I'm terrified by the fact that I did not get the same values. I did not get the same values. B to the 3rd, oh, a to the 4th, a to the 5th. I didn't get the same values. And that scares me. Because if I was correct, right, I think my answer, whoa, get back up here. I think my simplified answer is that I should be getting 3 times b to the 3rd. I think that's what I should be getting, but I'm not getting that. So what's strange is I'm sitting here and I'm thinking to myself, well, wow, I've made a mistake somehow, right? My simplified version and the original version are producing different outputs. That's just terrifying. And then I'm like, well, my gosh, how in the world am I going to check this? And I just kind of glance briefly and I say to myself, oh my, would you look at this, right? This was 4/3, and I was multiplying 4/3 by 6 over 2, which is 3. 4/3 times 6 over 2, 3. And I wrote down that that's the same as the number 3. You can see, oh, Mr. Roberts, you poor, poor soul. That's not the same, right? This should be the number 4. So I'm going to erase this, and I'm going to place the number 4 there. And I'm going to place a 4 right here. So my corrected answer, I hope this is right, is 4b cubed. Now, what's nice is because I spent so much time setting this up, and I know that exactly, I know exactly that when I evaluate the original expression, this is what I get. Well, check this out. I can just press enter. I'm going to clear this one, and I'm going to evaluate my answer again, which is 4 times b. And then I'm just going to raise that to the 3rd power. So 4b cubed, and I press enter, and I get, okay. So, you know, like I said, if you find that that was like 2 minutes. If you find you've got some extra time, right, and you're wanting to see if one of your simplification problems is correct, it certainly has to be the case that the original expression and your simplified version have to produce the same outputs. And if these do not produce the same outputs for any given set of A's and B's, then you know that you cannot be right, right? Now, I can't say that the flip of that is true. I'm not sure that I'm right because it worked, but I certainly can't say that I'm wrong. So I'm going to move on to the last one here, which is D. Simplify this. Okay, 12 over 4, I'm not going to make the same mistake twice. 12 divided by 4 is 3. So I'm going to have a 3 in my numerator for my final answer. And I can see that I've got an x squared, and then the denominator, there's an x to the negative second times y to the second. Now, I've been around enough, and I've been looking at this recently, that I know that x squared over x to the negative second is not a giant 1, right? For sure, if it was x squared over x squared, it would be 1, but this is not 1. So I'm going to intentionally, right, get rid of this negative exponent by multiplying the denominator by x squared. And when I do that, I'm forced to put x squared in the numerator also. So here's the thinking. X to the negative second times x to the second is x to the 0 power, which equals the number 1. So now in my denominator, right, I've got the number 1, and I've got times y squared. In my numerator now, you can see that I had the 3, but now there's an x squared times x squared, which is x to the 4th power. Get this calculator out of the way. So, right, this is 1 times y squared is just plain old y squared. And I've got this 3 times x squared, which is 3x to the 4th. So my answer for part D is 3x to the 4th, all divided by y squared. All right, let's move on to page 2. Page 2 says, solve this equation, include a check for your solution. A check is where you're just kind of verifying that the left and right hand side are the same. If you display that, what that number is, fabulous. So I'm asking you to do that for this problem. So as I look across this, I can see there are 2 different denominators, right? There's 4 terms in total. 2 terms are on the left-hand side, and there are 2 terms on the right-hand side. There are only 2 terms that have denominators, and the denominators I see are 2, and I see the denominator 8. It turns out 8, right, has 3 factors of 2 in it. That's 2 times 2 times 2. So multiplying both sides of this equation by the number 8 is going to remove all of these fractions. It will bust each and every one of the fractions. So I'm going to push a factor of 8 across this equation. When I do, I get the following, right? This becomes 8 times 3x over 2 plus 8 times 5 over 8 equals 8 times 12 plus 8 times x. Okay, and so visually I can see my intent was to give every single numerator or every single term in the numerator, if there's a fraction, a factor of 8. And you can see I put one here, 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 and here. Verify it. This got an 8, this got an 8, this got an 8, and this got an 8. So now I simplify, right? 8 divided by 2 is 4. 3 times 4 is 12. So this is 12x plus 8 over 8 is 1. So this just becomes plus 5 equals 8 times 12. 12 times 8. I don't need help with the arithmetic. 12 times 8 is like the number 90. I'm pretty sure it's 96. 96. And then plus 8 times x is 8x. Okay, so I'm going to subtract 8 x's from each side. That's going to give me 4x plus 5 is 96. And if I take away 5 from both sides, I get that 4x is 91. Therefore, I believe that x is 91 fourths. That's the solution, right? Now, how can I quickly check that? So, I don't know, get your stopwatch out. We're going to try. Let me put the calculator back up here. I believe that x is 91 fourths. So I'm going to type 91 fourths. There's that fraction. And then I'm going to store that into x. So my calculator now thinks x is 91 fourths. Let's look at the left-hand side. The left-hand side is 3x's over 2. And then I have to add to that 5/8, 5/8. When I do that, on the left-hand side, I get a syntax error. Why? Because this was supposed to be plus. And I don't know. What did I enter? Plus? Okay. I don't know what I entered. So when I add those two, right, 3x over 2 plus 5/8, I get 138 over 4. What about the other side? The other side's simple. It's just 12 plus x. When I do that, I get, 139 over 4. So when x is 91 fourths, both the left and right hand side are the same. In fact, the same that they are is 139 fourths is the same as 139 fourths. So this is my check, right? I don't have to do more than that. I'm just confirming that when x is 91 fourths, both sides are the same. Let's move on to the next question. The next question says, evaluate this expression for the given values of a, b, and c. We're told a is -4, b is 2, and c is 1/3. So I'm just going to do some substituting in here. C is 1/3. Got it. Open paren. 2. B is the number 2. Got it. Plus 5. Close. Plus b is the number 2. I'm going to square that. And then subtract. A is -4. So I've used parentheses to plug in everything here. And if I do a little bit of simplification, this set of parentheses is 4 plus 5, which is 9. So this looks like 1/3 times 9 plus 2 squared is the number 4. And then minus a -4 is going to be plus an additional 4. Okay. 1/3 times 9 is 3. 3 plus 4 plus another 4. So I'm looking at 8 plus, 8 plus 3, 8, 9, 10, 11. So I believe that this is 11. So for these values of a, b, and c, this expression produces an output, a value of 11. So that's number 4. Number 5, it says find the slope of segment AB. So just for segment AB, I'm going to look at the furthest point to the left. Here it is, it's A. And I'm going to go down from here 1, 2, 3 units. And then I'm going to go to the right 1, 2 units. So I can see that the slope of AB is down 3 over 2, -3/2 units. Next, it says find the equation of a line through point C. Okay, and I can see the coordinates of C. C apparently lives at 3, 3. So find the equation of the line that goes through that point and is perpendicular to segment AB. All right, so lines that are perpendicular to each other have slopes that are opposite reciprocals. Segment BC had a slope of negative 3/2. So the line I'm looking for is going to have a slope of up 2 over 3, positive 2/3. And actually, if I go ahead and sketch that from point C, I can go up 2 and then over 1, 2, and 3 right there. And what's nice about that is I can already convincingly see, right, what's happening. In fact, let me just extend that line out. So as far as it looks to me, right, it certainly looks like my y-intercept is at positive 1. So it says find the equation. So it looks like the equation is at the y-intercept's at positive 1, but I'm going to verify that. And the way that we verify it is, remember, we're thinking, hey, because for any line except for vertical ones, y equals mx plus b. So I have an x and a y, and it turns out they're both 3, right? X is 3 and y is 3. So I can put in y is 3, and that equals 2/3 times x, which was also 3, plus b. 3 is equal to 2/3 times 3 is just going to be the number 2 plus b. And if I take away 2 from both sides, I get, yeah, my y-intercept is at 1. So the equation of this line is y equals up 2 over 3, 2/3 x, and then plus the number 1. And then I already did part C just by default, right? Just by drawing it, I got this there. So here we go. We have this line, right? This line that goes through C, and this line makes a right angle with AB, right? I know the equation of that line, I know the slope of that line, and I know that it has a y-intercept at positive 1. Next, it says find the equation of a line that is parallel. Oh, parallel to this line. Well, lines that are parallel to each other have slopes that are the same. So I'm just going to remind myself, same slope. And this line, it's very easy to see what its slope is because it's written in slope-intercept form. Its slope is 1/3. So what's happening here is I'm being asked to find the equation of a line that has a slope equal to 1/3. And it goes through this point where x is 12 and y is the number 9. Same thing I've done before. What am I going to write? I'm going to write y equals m times x and then plus b. So I did it without writing it, right? Y, which is 9, equals m, which is 1/3, times x, which is 12, plus b. 9 equals 1/3 of 12 is the number 4 plus b. That means that 5 should be what b is. So I think the equation of the line is y is equal to 1/3 times x plus 5. Now, I can check this in two ways, right? First of all, does it have the correct slope? Yes, it has a slope of 1/3. And also, if I plug in that x is 12, does it give me 9? Well, yeah, because 1/3 times 12 is 4, and 4 plus 5 is 9. So this certainly does check. So our answer to question 6 is y equals 1/3 x plus 5.